Hi everyone, welcome to another Wolfram language design review. We are looking at various items, part of our incremental language development series. First up, LogPDF.
Yep. So this was a question you had posed yourself, which is the machine learning group has their own log PDF function, and should we move this to system? So I've kind of collected bullet points from the discussion, both with the ML team and the stats team. Both that the generic version of log PDF is basically log of PDF, but there are distributions which sample in log space, and there are also some internal utilities that already exist for log likelihood. And so it looks like, beyond just having a trivial log of PDF of a distribution, there is some actual benefit to perhaps having a built-in
I think we should. I mean, like we have a log gamma function because that's a thing where it's, just, yes, you can take the log of the gamma function, but it's just a better idea. I mean, now what about log likelihood? Is that a thing for which we should have? And we have
we do have log likelihood and we have likelihood. Likelihood is the products of PDFs and log likelihood is the log. So it's the sum of logs of PDFs.
Okay, so how does log PDF relate to log likelihood?
Log PDF would be a single element version of log likelihood. So what we have derived formulas for the parametric distributions for log likelihood. And we could use them to maybe implement the log PDF, in the same fashion as the PDF is. So that means, make it like a proper distribution function for every distribution.
Right. So in this case, log PDF of a normal distribution. Wait a minute, that's a multinormal, is that right?
No, because it's the function PDF, it's listable. So if you
yeah. So I mean, can I get this? I could probably get this particular one by just saying log of PDF of that comma X, probably. Is that right?
Yes.
Except actually it doesn't simplify. Why doesn't it simplify?
Because it's just the log of an expression. So either you do the function expand as above of that.
Okay, but even that hasn't simplified because it doesn't know that X is real and so on.
Right. So yeah, that's where the need to kind of implement this properly comes in, because we know the assumptions on the data, we know the assumptions on the distributions.
Also, the one above is numerical, so it's not for the generic X. And I have to say, one advantage, I mean, the reason why we have it in machine learning is that specifically for numerical evaluation, the log PDF sometimes is more well behaved. So yes, you might have some numerical instability in the PDF.
All right, listen, let's have log PDF. I see no argument against it, and I see lots of arguments for it. Any objections?
No.
Okay.
All right. Easy
let's
enough.
Make it happen. All right. Next up, and let's see, the people who are here for log PDF can probably depart.
Yep. So that'd be Gosha and Julio. You're welcome to step out if you want.
Thank you.
Bye.
Okay, tree traversal order. Why on earth is that smart quote the wrong way around? Who knows? It's a bit odd. Looks like a bug to me.
Yeah. Strange.
Okay.
So this is a missing variant of depth first for binary trees. And so I'm proposing here a generalization so that we can add it for any tree.
Okay, what does it mean?
In order means that you visit the parent before you visit its right child, but after you visit its left child.
I don't know why in order is the right name for it.
It's the standard name. There's pre-order, in order, and post-order. Pre-order is parent.
Do we have pre-order?
Right. Yeah. Pre-order is top down.
All right, so there's just a missing thing. So what's this -2 here?
So for binary trees, in order has a standard definition. For general trees, we have to decide where you want to insert the parent.
Well, we're not going to, I mean, look, don't we have most of these tree traversal order things just have, it's just a string, right? There's no parameterization of the string.
Right. This would be the first parameterized.
I don't think it's a good way to do it. I mean, I think that, hold on one second.
So you got in children, you can
Yeah, I
insert
understand.
n+1 positions.
I understand. I mean, you might want even crazier things, like you might want, well, I guess it's a traversal order. So you're only going to hit the node, the parent node once. Right.
Right. Yep. So I'm suggesting in order means always after the first child.
Yeah, I understand. I'm just not wild about the way of adding parameters to this. Don't we have, I mean, vertical order, horizontal order, what's this? What does that mean? Vertical order?
So for base orders, we've got depth first, breadth first, and leaves first. Those can be combined with top down or bottom up, and with left right or right left. So in order would be a new vertical order that only applies to depth first.
This here. Okay.
Yeah.
But to me, this question of where the parent is inserted is very similar to this left, right, left stuff, isn't it?
It's most closely related with the vertical order.
No, but not the question of I mean, this is determining in which order parents and children are visited. But this is determining
the order of children.
No, I understand. Well, I mean, okay, a good design idea here. I really don't like, I really don't like this. I mean, and you can't use a list because you've already used a list for this case here, right?
Right.
I mean, look, to begin with, it could just only work for binary trees, which is probably the only case anybody's ever going to try to use it for.
Could you make a 4-element list where the parameters are the 4th element, and then you support automatic for first and third?
No, because
that would commit the parameter.
Yeah, it's not worth
only
it.
being a particular thing.
Look, the thing that's clearly doable is just make in order work for binary trees. And for non-binary trees, have it do the default thing of just putting the parent after the first element.
Mm-hmm.
What about a spec order bracket 3? A pair with a name and an association with any parameters. And then there's no ambiguity with the 3 items there.
Say that again? I'm sorry, say that again.
So you can have the spec be a pair, a list with 2 things, the name and an association of parameters optionally.
I see. You mean, well, the other thing to do, which is clearly the way to go, is that tree traversal order can end up being an association. And, this could be called the, base order arrow, whatever, vertical order arrow, whatever, horizontal order arrow, whatever. And then this other thing, look, look, I think what we should do is just have the in order case. Just say it is defined to put the parent after the first child node. Period, end of story. The ornate other case is going to wind up being, I can think of a gazillion okay, this thing here is in general the definition of a reference frame, basically. It's something, I've written now quite extensively about this. It's, there are these named cases, but there's an infinite number of other cases. You see what I'm saying?
Yes.
Right. You might have something fully parameterized where
right,
your insertion order and your, like you said, vertical order, horizontal order are all different. So
right. I think we should just make in order be, for binary, it will do exactly what you would expect. For an n-ary tree, it will put the parent node after the first child node.
Yep.
Does that seem reasonable?
Yes.
Why are you putting parent after first child?
Because that's as opposed to after last child,
or before first.
If it's before, that would be pre-order. So, if you want to be consistent with binary trees, you could either put it after the first child or before the last child.
Oh, so you're talking an infix type. Okay, sure.
Yeah.
Yes, but so the only question is, which of those do we want? After the first child or before the last child?
Can I ask a dumb question? I'm going to anyway, whatever the answer. Is there some reason that we don't want to have it after each child other than the last?
Yeah, because it's a single, that was what I was thinking as well, but it's a traversal order. You only visit every node once.
Okay.
And I think it is interesting to consider traversal order potentially being able to revisit nodes, but it's not something we've tackled.
Right. How about the following thing? Maybe we need in order and then some word that means it's going to go after the first child, and another word that means it's going to go before the last child. And then it's just a pure in order.
Maybe it's like in order left, in order right.
Thinking in order penultimate. And
I mean, the long phrase, I guess, would be in order left child, in order right child, but that's
I'm not even sure that's right. I mean, I think it
you can use this along with
penultimate.
You can use this along with left, right, and right, left, can't you?
Yes. Mm-hmm.
So those would become misnomers if we put left and right.
Yeah. Let's just have it. Okay. Put it after the first child. Period. End of story. That's what we're going to support for in order. For binary trees, it will do exactly what you would expect. If you happen to have an n-ary tree, it will not do something crazy.
Yep.
And recognize that these are simply named traversal orders, and there are an infinite number of other traversal orders which we didn't happen to name, and we're just trying to name useful ones.
You can accept like an arbitrary function, so that like an order actually ask for which child where the position to insert your parent, something like that.
Yeah,
then you can at least specify in order manually.
Yes, but the problem is what you want. The problem is most functions will fail. Okay, in the following sense, that what you need, an order is an order. It's a sorting of nodes. I mean, I could imagine something where the tree traversal order is literally a list of what nodes to visit in what order. Am I making sense? I mean, these trees are always finite, so.
I mean, you can always do that now with tree position. You can just ask for the list of positions in any of these traversal orders.
Well, I understand that, but I'm saying, let's say you want to traverse the tree in some random arbitrary order. You see what I'm saying? How do you do that?
Yeah, we don't really have good parameterizations for different spaces right now. This in order with a parameter would kind of
I know, but we don't want to do that. We don't want to do that. What we want to do is you are given a collection of tree node specifications, tree positions. Okay? your mission as an ordering function, as a traversal function, is to put those positions in some order. See what I'm saying?
Mm-hmm.
Right? So is it the case, and I'm thinking it should be the case, that there is a tree traversal order arrow, and then it's simply a list of all the tree positions in the order you want to visit them? That's the general case.
Yeah, except in some sense, because it's a tree structure, unless we have hidden structure behind it, you're going to end up traversing the tree in some other order just to get the order that was requested. In other words, you have to find the 47th node. So at the very top, do you go left or right to get to that? And you're going to be chasing
it depends what operation
branches.
you're doing. Yeah. All right.
I'm not saying that's the wrong thing.
Okay,
I'm
listen,
saying
guys.
it'll have to happen.
This question about the traversal order of trees or in general DAGs is the giant question of reference frames, causal orders. It's a thing I spent a bunch of effort thinking about. It's, we don't have, in general relativity, for example, where we have exactly this kind of issue of finding, families of space-like hypersurfaces and so on. There are just particular named metrics that one typically uses. Just like here, we have particular named traversal orders we use. And generalizing beyond that is really hard. So I think we should just not worry about this. I think we should put the in-order thing in, and, we made some serious effort to try and generalize this, and it has not been easy to do. It relates to the multi thing we're about to discuss. Go ahead.
I want to say, in my own uses of tree traversal in some of our kernel code, there are actually reasons to want to revisit intermediate nodes. You drop down to the children, then go back to the parent, etc. And what I'm wondering is, in the context of this tree traversal stuff, if we want a revisit option.
I don't know. I mean, do we have that in breadth first scan?
I suspect we do not, and I think when I was looking, it was something I was missing. I don't know that for a fact, though, and it's very possible I just didn't catch the documentation.
But I mean, this is kind of map at different levels, is it not? I mean, you could just have a big list of places where you want to apply a function.
Well, no, this is a bit different. This is when you want to traverse the whole tree, but you need to do some things at parent nodes, both before and after visiting the kids, that sort of thing.
Yeah, I understand. I mean, look, the functions depth first scan and breadth first scan have not proved very useful. They're too complicated to use for the most part.
Yeah, well, maybe I'm adding too much complexity with that suggestion.
Well, and then we have this Brad's directed acyclic evaluate, which needs a better name, but is something I think we should look at.
Vertex weight fold was one that we discussed last time.
Wow, which is another name for directed acyclic evaluate.
Yeah,
I don't see an improvement on
that. No. Yeah, I mean, you know what it is, right? There's a function at every node, and you are basically running the function at every node. So in other words, you think of the thing as an expression tree, and you're evaluating it by, actually applying that function to the child nodes. Does that make sense?
Yeah. I think of it as a generalization of treefold. In trees, you have this depth first order that tells you the dependencies, but in a DAG, this reference frame stuff comes up.
Yeah. Yeah, your point is treefold is, I mean, perhaps what it really is graph fold.
There's a fold graph function already.
What the heck is that?
But directly acyclic evaluate, it is a fault, but I would call it something like a path fault or graph path fault, because it's really coding along paths with some custom functions that you can provide.
But I mean, wait a minute. What is fold graph? I mean, and where is it? Is it in the function repository?
Yeah. Fold graph. It is like a fold, but it produces a graph.
Okay. So it's like, I mean, nest graph. It's like nest graph.
Yeah. Yeah.
Let's see.
Is this like there's nest list and nest graph, and this is a straightforward thing for fold?
Yep.
Oh, you have lists. This is multi somehow.
Oh, this is yours, Nick.
Right.
Yeah, fold with multiple inputs.
I see. Okay. So this is different from graph fold, which is take the graph and use it as the material to fold. I see, but the problem is it really is graph fold graph, is it not? Or is it, no, wait a minute. What does directed acyclic evaluate return? Does it return a scalar final result?
It returns a weighted graph.
Not usually the same graph, right? You just weights it. Or basically just weights.
Yeah, okay, but so there's an alternative.
It flows the weights across the graph and then returns the graph.
So, okay, but there's a different thing you could do, which is just evaluate, just do what fold does and evaluate, like on a tree, for example, tree fold, that's what it's doing, right? Tree fold is giving you a final result, is it not?
The thing is with fold and with tree fold that they have this relationship with the algebraic data structures for lists and trees, and that's not clear to me for DAGs.
What do you mean algebraic data structures? You mean,
like what? How do you a graph? A DAG isn't usually expressed as a combination of like operators. It's just a big bag of lists, and so it makes me nervous.
Is it this? Can I do
call
this?
it graph fold? Yeah. I like vertex weight fold. Gives you some idea of what's actually happening.
Well, it may not be the right function in terms of functionality. So what the heck is this doing? So this is taking, this is treating, let me do this on a simpler graph. Whoops, that's giving me a graph, isn't it? How do I get the corresponding tree?
You can do graph tree of that.
Okay. Okay, let me try to understand this. So if I were to look at the input form of %8, and I get rid of these tree common nuns, basically what's happening is I replace tree with F and I get this. Is that correct?
Yeah. Actually do tree fold of tree, comma, %8. Fold, not form.
I see. That's what I would. So
the tree is like a fixed point.
I hope you put that in the properties and relations of that function.
I believe so.
Okay. I think we should have a separate discussion about directed acyclic evaluate. And
yeah, we'll plan to have that one of the weeks that Brad's available.
Okay. All right. Okay, should we move on? Okay, let us dive into the grand world of multi. So where have we left off with multi?
So we were talking last time a little bit about the multi as a container value in superpositions, and it was kind of related to
what's this?
Cycling.
What's this? What's this?
Just ignore it.
Really? Why am I getting this error? Shall I quick and restart?
No. Well, it's not an error. I think just about missing hypergraph packlet. Because
So why is it missing?
I thought, well, ideally it should have been installed. I don't know why it can't be installed though.
What the heck is this?
Well, maybe you can install it, but it doesn't depend on it anyway. We can just move on.
Okay,
The
but
multi,
yeah,
multi isn't related to that.
Okay, but in any case, we should debug why this is happening. But that's a separate thing from this.
Well, it's just how I made the packlet. Maybe, well, it's supposed to be installing the hypergraph when you load it, but I don't know why it's not doing it.
Okay, but we need to find out why it isn't. But not
right. That's
for
a
right
bug. That's a bug in his in his code, in his packlet code.
Okay, fine.
Down and fix it.
Okay, all right. So now, what are we seeing here?
So last time we looked just through all the sections briefly, right? We can just start from the superposition and all the multiple ways of using multi, because it's really multi-purpose thing.
Well, so for example, if I wanted to implement the function multi-way system using multi, how would I do that?
You create your multi and then there's like one property that is called edges. Maybe that's the most simple one. It creates a single level of edges from your initial condition to all the possible values it can produce, whether they're explicit values or rules or whatever. You can then just take those edges and create new multi-object and iterate.
I'm fairly confused. Okay, let's take it from the top. I don't understand. The arguments to multi, I thought, were just expressions that are sort of in superposition. Is that wrong?
Well, not really. You can either use a list of values or you can use an expression and then you provide a list of rules. But this expression also can contain arbitrary definitions, so it also be going to be applied as rules.
Wait a minute, what's the point there? There's an explicit version of multi where you have all the material, and there's another one where you're generating on the fly. Is that the idea?
Yeah, basically you specify how to generate things using rules instead of explicit values.
Okay, I don't understand what that f of multi of 2, 3, 4 means. I mean, that looks to me like just a single expression that doesn't do anything.
Yes.
No,
I
now
mean,
if
it
you
should.
combine it with the second multi, then it's would be more useful.
All right. So if I take this,
it means f of 2 and f of 3 and f of 4 in superposition. Somehow.
Right.
Is that?
Yeah, that's what it means. So if I take this and I say like 2 times this or something. Okay, now how do I get an expression out of that?
A single expression, or well, we can
I want to get
ask
the whole
for
thing.
normal doesn't work like that.
Okay.
You can
So how
ask
do I
for
get the whole thing? Go ahead.
It's list values, right? You can list values.
The heck does that
So
mean?
that's
Where's the
second.
F? Where are the Fs?
Try evaluate values. Or evaluate list. Don't remember. Let me check.
And it also doesn't look like 9 values.
Evaluate list. Yep.
So.
Okay. So that's really a defining difference from listability. When multis combine, they outer productize. Correct?
Yeah. So we combine multi with 3 values and with another with 3 values. Now you have a 3 times 3. In total, 9 values. So that's why.
Okay. So if I say AB, if I say list multi AB, multi XY. Oh, for God's freaking sake. It should be displaying better than this. But anyway, let's not worry about that.
Well, I mean, when you have an infinite number of values, it's probably
tough to display it. Yeah.
So this is when you have 2 multis at the same level of an expression. How does this work if there's a multi at a lower level?
It doesn't matter. It can work on any level.
So if I say f of that multi, comma, g inside that multi.
Mm-hmm. And there's also an argument to evaluate list. If you can ask for a single or 2 values. So how many? So it kind of has some laziness built in. Because the outer product usually get very big very quickly. But
right.
If you want just the first one, you can ask just 1.
Right. So now in general, I mean, there's a graph, right, from the, well, let's see. Now, each of these things has produced a space-like slice, basically, or actually a branch-like slice. Is that right, Nick?
Yeah, you can think of it like this way. Yep.
Okay. But now there are operations I can do. Let's see, if I do a nest list, how do I get something that is like, and if I say nest list F multi.
You really have to be careful because this is going to be just absorbed to the nest list.
I don't understand.
It's like you have to hold it or use and evaluate it, but it's not going to always work. No,
this means you could have, this means nest list on X and nest list on Y.
Yeah.
Yes. But I mean, my question is, well, does it mean that, or does it mean the thing that's going to outer product bigger and bigger at every step? See what I'm saying?
Well, you see the placeholder, right? You just substitute in that particular placeholder all the values that you specified. It's just an expression.
Yes.
So what was your question?
The outer product here is just 2 elements. You're not getting like. The
there's no
multiness
product.
is not nesting in this example. Multi is just treating nest list like any other expression.
Right, but it would get more complicated. I mean, the thing that I'm wondering about is if I say f of multi xy, comma hash,
What's that hash supposed to do?
it's supposed to absorb the next thing here.
That's a second argument to multi.
Oh, I didn't need to put it there. Okay. What does this do?
Right. The multi is super aggressive, and so you basically get you're experiencing the joy of having zero evaluation, and so you must force evaluation at each step.
Why didn't this evaluate to a list?
Because you have multi inside, so it was produced. Maybe it produced a list, but it was a list of multi, so it got absorbed again.
How does evaluate list decide whether to return a list or a multi?
Oh, it doesn't decide it. It always returns a list. But if you return a list of multis, then the up value for multi fires, right? And now you get a new multi again.
So %8 isn't a multi just because there were no multis in that list.
Right.
Wow.
Okay. But so, okay. Imagine we have, I mean, basically function composition is, I mean, from a category theory point of view, it's kind of like there are morphisms and then there are, oh my God, what are those? Monoidal categories, right? Which are and so this multi, I mean, we've got,
yeah, it's like a tensor product. So we have horizontal composition too.
right. So this is vertical composition, and then multi of FGH is horizontal composition. Is that right?
Well, in some sense, yeah.
But in general, a graph, by foliating a graph, we could turn it into a collection of multis, of compositions of multis. Is that true? If you have a DAG, you can foliate it into compositions and multis.
I think so, yeah. I don't have like a very well developed intuition yet, but
I think it's like any resistor network.
Tree, and then each branch is a multi.
Possibly, yes. Every time it branches, it's a multi. That's possible. I think that will be a good function to have, is something that converts a graph or DAG into function compositions and multis. That would help us to make sure we understand what's going on. Now, you know, if you have something very mundane like a resistor network, presumably, if I'm not mistaken, you can represent that by, you know, a combination of series and parallel circuits. Am I making sense? So I think
we get a string diagram. That's the next topic.
Okay, well, let's look. What are these called? The things where you have, who knows how this works? state space models and so on?
I do.
Okay. So is there a thing for doing parallel series?
Systems model parallel connect is a function.
Oh yeah, there's systems model series connect, systems model parallel connect. So is this not analogous?
I suppose.
I mean, and then this thing is giving some evaluation of those, these transfer functions. I think these are all analogous.
Right. It grows the size of the state in the system when you connect things in parallel.
They're all monoidal categories, basically.
Yeah.
And they can be made into a diagram, the string diagram.
Okay, we should look at that. What is feedback connect?
That connects the output of the first system to
I
the
mean, I
second.
understand what it is, but what
versa.
is that? What is that in the world of? I mean, that's a closed time-like curve in our physics
Trace,
world.
maybe. I think it's a trace.
Does it take a trace, or does it make a closed time-like curve?
Well, I mean, the closed time-like curve is a trace, because when you have this feedback loop,
I see.
Is essentially the same as tracing your matrix if you have some matrix representation of a diagram.
Yes. Okay, let's go on and look at string diagrams for a minute. And then this is very weird. This thing with rules inside a multi is totally weird to me. Can you explain that?
Well, try evaluating it. Let's explore some of the properties. I actually have a newer version of the agenda. There are more examples there.
Okay. Can you send it to me?
Yeah. Chat. Maybe not for the multi-way system, but in general. There are a bit more examples.
Nick, is the case of just a list of elements, is that just equivalent to a list of rules with an empty list on the left-hand side?
Well, I was thinking about it.
Rules.
It's not quite equivalent. You can't really come up with a rule replacing some particular placeholder. Or maybe you can, but it's going to be much more awkward. So I kind of decided to leave it two of these different uses. So in a way, if you have a placeholder, the main difference, I guess, is when you have a rule, it doesn't have to necessarily be applied, right, at some particular position. So you can apply it at some part, but some parts of the expression are not going to change. But the placeholder always can have a value, always should have a value. So if you ask for evaluate list, all the placeholders should be replaced with some values, but not all the parts of the expression would be replaced with some rule because a rule can't be applied. Or whatever. It's complicated. It made sense to have the separate use cases.
Let's understand this. I don't get this at all. I mean, I don't understand. I thought multi had a list of expressions in it.
Well,
that's one expression.
But you have rules, so right, you generate all the list of expressions from the. At least that's my understanding, right?
Yeah, right. I think that should be a different head. I think that's a sort of a multi-rule or something head.
Should evaluate to multi or what?
No, I think it's lazy.
Can you have an infinite number of elements in the list using this form of multi?
Yeah, probably. I mean, to me, there's a multi-list that is just the raw list. Okay? That's just raw list of elements.
Yeah.
And then there is a generator, multi-generator, let's say, which is a function. And now that I'm a little bit confused. That function is applied to what? An expression or a list of expressions? And that function...
You don't have to have a function for generate. It can be an expression, and then you can add a rule that just produces different right-hand sides, depending on what your expression is. Right? Basically, a rule is the same as the function.
Well, okay, fine. I mean, we could say multi... Look, I mean, that's not very... You know, this is a function multi. Okay, these are bad names, but this is a list multi. A function
association multi.
Well,
I would rule multi.
Well, I would say that it should be X per F for consistency.
Why for this one here?
Right. Well, at least what he has there is X per rules, right? So
I know, but if we're going to do, okay, so let's say rule multi is this. So then that's I'm not a little bit troubled by argument.
Is it because map is F comma X per, the function multi wants to be F comma X per?
Yeah, but be that as it may, these are generators of multis. So for example, in the case of our multi-way systems, we have a ridiculous zoo of multi-way functions that, you know, multi-way function, multi-way system, multi-way Turing machine, blah, blah, blah. Am I making sense?
Yeah.
Yeah.
And this would avoid that. This is three cases: the explicit one, the function one, and again, these are all potentially lazy. Am I making sense?
Yes, and should there also be an association multi?
What's an association multi?
You're like naming the branches.
Yeah, possibly.
You might already.
Although, does that really need to be separate from the list multi?
Probably not. I mean, it's that.
Obviously, it needs a better name, but
yeah, right. I mean, it's almost like two multi or something. I don't know, but okay. But given these things, you then just, you know, how would you make multi-way system with these? That's a rule multi, correct?
Okay. So we just iterate it over, ideally.
Well, I think it's just nest list of rule multi or nest of rule multi.
Yeah, but you still have to somehow produce a list of edges, not just list of multis for each level.
I understand, but I mean that's why I see what you're saying. So it's more like nest graph.
It's nest multi.
No, but the multi is a slice. Remember, the multi is a slice. The history is more than just the slice. I think we need to look at string diagrams.
This is just a reminder that we have it in quantum frame, for example.
So how is it represented there?
You just basically specify a list of your processes, right? And you specify what are the inputs and what are the outputs, but essentially naming them so that you can knit together the whole diagram. Your inputs has an order, your outputs has an order. They essentially named indices. You can connect it to a diagram.
So every port has to be unique across the whole diagram. Is that true?
Not necessarily, because you also have this specific layer, because we're only dealing with circuits there. So you can name it by an index of the wire that runs horizontally. So we have 1, 2, 3 wires, vertical wires. Right?
I see.
Those are the names. You can just specify what whether this particular wire is an input to your process or the output. And you just specify it by list of these operators that has some inputs and outputs. in some order. Those would essentially be a topological order of your operators. Then you can make a diagram, turn it into a network, and so on.
And how does this relate to what we do for neural nets? It's basically the same, isn't it? I mean, it's a net chain thing where you've got ports going into other ports. We've got both net chain and net graph.
Yeah.
I mean, what's the relationship between I'm confused here. What's the relationship between the net chain, net graph world and this world here?
Well, they're very close, right? Because the diagrams, what connects them together, they have, and the diagrams contain some elements, again, composed either vertically or horizontally. That's your monoidal category again.
Yes.
Just in the quantum world, you have some quantum gates, which are some kind of tensors that you have to then multiply together to get your result. In the neural network case, you have a bunch of layers that you again should just
basically
run
tensors you multiply together to get your result.
Yeah.
Okay. But in our multi-way system, so that multiply together to get the result is like directed acyclic evaluate, is it not? And it's also like the transfer functions.
Yeah. I think the neural network case is different because the tensor product, this horizontal composition is kind of different. It never has some layers taking like multiple inputs in a way, right? Because unless there's some aggregation. But
yeah, there can be aggregation.
But in some sense,
basic point is this, I think. Our traditional model for functions, being applied to functions and so on, is this tree structured expression model. What everything we're seeing here is a generalization of that. It's graph structured expressions, or at least DAG structured expressions. Am I wrong?
No, they're not structured by graph. They're again structured by this two types of composition, vertical, horizontal. You can turn it into a graph. And string diagrams also has some nice properties that you can reduce a bunch of wires and actually turn your compositions into just a graph.
Okay, but I mean, I'm trying to understand.
Wouldn't a more general form not require to be acyclic?
I'm not sure. I mean, that's what the feedback thing. Yeah.
Because I was also working on something that I'm tentatively calling LLM graph, which is also related to this stuff. And one of the things I was exploring is the possibility for it to loop under certain conditions around certain points in the graph.
Let me understand that. So the LLM, I mean, for example, a standard LLM, are you thinking about how the next token is handled?
No, so you can think of it as like, picture each node as like an LLM function, right?
Mm-hmm.
And you basically define a graph on these nodes where the output of some are fed into the inputs of others, and you can have named nodes. So, your string templates just pick up the outputs in the right spots. But one of the things I was looking at was like, what if you wanted to retry one of them multiple times until a certain condition is met, something like that?
Mm-hmm.
You might end up with something that is an infinite loop, but
yes, I understand.
If it's defined well enough, it probably wouldn't.
Right, but so what you're saying is, I mean, this is a flow of data story.
Yeah.
You have a flow of data through string templates.
Yeah, and I've been using NetGraph as sort of like the mental model for how to put it together, but that's the major difference. I'd like to have the ability to make it cyclic in some ways. I haven't figured out how that works yet, though.
This is like all about representation. As soon as you have for your diagrammatic process in general, as soon as you have representations for those special arc processes, I have an example. The top on the left you have this cup process, on the right you have then another cup, right? As soon as you have these processes and representation for those, in case of linear algebra, there's some special states and effects. In case of maybe some computing, they even can represent some promise, right? And the resolution.
Which thing is a cup? Is this a cup? What's a cup?
Well, in the quantum case, it's just a Bell state. It represents a state in the superposition.
Okay,
right?
yeah, okay.
So you have a representation for that. In some other diagrammatic process, if you have a representation for this kind of process, for this cup thing, so that you actually can manipulate the whole diagram as strings, then you can do some nice simplifications of the diagram and reduce it to much simpler forms.
Where is there a string here?
Oh, the wires are strings.
Okay, fine.
Right.
So, okay, first question. There's got to be somewhere some dictionary that somebody's made of all of the different meanings of string diagrams. If not, we should try to make that. Am I making sense?
Mean to collect all possible type of that's I think the process theory. That's all about that.
Yes, I understand, but I'm saying the actual uses that we've got now. We've got Rick's LLM string diagrams. We've got control theory. We've got net graph. We've got quantum. We've got multi-way systems. Okay, we've got game graphs. We've got a whole bunch of different things that are all the same idea over and over and over again. Am I making sense?
Is there a purely graph theoretical version of this?
Well, I mean, these are very labeled graphs. They're both labeled and evaluatable graphs, both of which are not, communal garden graphs. Okay, let me make a meta comment here. I am sure that there is a nice, sort of clean overall language design. This is I have to say, this reminds me, this is let's get it done now, because I tried to think about this in the mid-1980s of kind of graph-based languages. And, one of my things of the 1990s, probably late 1980s, early 1990s, was, we have infix operators, we have prefix operators. I had this idea of graph fix operators, which is not quite this, but it's something close to this, I think. Do you see what I'm saying? So that would be a case where you are looking at the flow of data into and out of functions, and the functions are on the edges, but that's not what we have here. Is that correct?
Functions are the vertices.
Yeah, that's what I think. Right. Which is also what we're doing in the case of expression trees. The functions are vertices. Correct?
But you could represent it either way if you chose to.
As a which?
If you chose to represent it the other way, it's possible, though, right?
Yeah, sure. But I mean, it's just like, but we have a whole model. I mean, our whole language is based on tree-based. Okay, we have a little bit of a different situation because in our trees, it is not the nodes of the graph that are the heads. It is kind of a side node, if you understand what I'm saying.
Right.
So when you convert a, for example, if we convert an expression tree, right, so this is expression tree of f of x of g of a, b, oops.
So there's a whole zoo of ways to convert this expression into a tree. There's not just one tree representation.
Right. And this is the one. Right. This is what I mean. Okay. Yeah.
The older legacy, what was it, tree form, I think?
Yeah.
That shows it in the form you were just talking about, where the heads are like side nodes.
Can we get that here? What is the option here?
Do sub-expressions, and you probably want heads goes to true.
Okay. Okay. All right. Well, look, the basic point is we have this very nice compact notation for expression trees. You know, f of x, blah, blah, blah. What's the thing we want that represents essentially, I mean, you know, we need to understand this correspondence. This is a trivial string diagram. Is that a true statement? We could write that as a string diagram.
Well, as I said, you need just two types of composition to make the diagram in general. That's like if you click on that diagram process resource function on the bottom, like for these things. That's how I've been representing it. It's an old thing. So like just look at for some examples. You basically give it an expression, kind of just specifying your inputs and outputs, but you can compose them either using a composition or the tensor product composition. That's how you specify how they are composed, sequentially or in parallel.
Yes.
That's how you can build up the whole diagram. And then the diagram can have different meanings, different representations. It can either be interpreted as a linear algebra thing, and those are things are tensors, and you can contract them, or they can represent actual functions that run either sequentially or in parallel, right? Or your
but wait a minute.
machine.
There's a single way in this case. I mean, composition is not. We assume in our composition that, you know, f of g of x is just a one argument composition. In more generality, we could have something like, you know, f of hash a at star, you know, g of b hash and so on, right?
Yeah. Well, if you specify the actual which output of which function goes into which input, or whether there are multiple outputs, if you can all specify that, you can turn it into a diagram.
Sorry, can I say something here? So I think here we have a natural nesting of functions and their arguments. So there is some sort of natural direction in which things are nested. With tensors and linear algebra, one thinks that one have a function of a vector, a linear function of a vector. But because of how linear algebra works, one can also think that the vector is the outer function of the function, right? So there's this duality. And that duality makes things symmetric. That's why we can use symmetric notations like u dot v or uava, right? So, so in linear algebra, we have functions, but there is a symmetry added. And that makes the notation symmetric. And that's why these diagrams do not need a direction. So with functions, you have inputs and outputs, so arguments and outputs. So there is always a directed graph. With tensors, the connections are not directed because you don't need the direction. It's all symmetric. The contraction is symmetric.
Right.
The functional application is symmetric because you can think of linear function of a vector or a vector of the linear function.
There's a way to make sense of direction there. Because I have arrows there, they essentially represent the flow. Basically, if you conjugate this diagram, you can conjugate them. And if your actual tensors are complex, those would actually mean the complex conjugation. So there's some interpretation you can add to the direction of arrows too, even for linear algebra. That would mean
well, in the quantum case, right, which is a little bit. What is the complex is the quantum case like complex linear algebra or what? What is it like?
Yeah.
Okay.
It is. Yeah.
For which the arrow direction, but which is not something that comes up in general relativity, because the tensors are not complex. Or does that come up in spinner indices and things?
Yes, spinors are complex, and there is an antisymmetric metric. So up and down are not symmetric. The metric is antisymmetric.
Right. So then there are arrows needed in that case, are there not? For spinner algebra as opposed to linear algebra. I mean, ordinary linear algebra.
I'm not sure, because I mean, your spinors, you know, in the object what is up and what is down.
I see.
Just
So
arrows not gonna change the result of tensor construction, right? It just changes the representation of the diagram, so that there are some certain operations you can do with the diagram and the tensors. It just makes sense to add an arrow when you want to, for example, transpose the whole diagram, or reverse it or inverse it, or take the Hermitian conjugate, so that the arrows kind of also flip around.
All right, we should wrap this meeting because I've got to go to something else. But maybe you guys, I mean, it's clear there's a real thing to do here. We need a whatever, string diagrams, diagrammatic processes, you know, whatever we want to call it. But we need a generalization of essentially our tree structured expressions mechanism that deals with, you know, that deals with this case of parallel function, you know, this parallelism, the monoidal category case, so to speak. Maybe you guys could, Ian, Nick, Jose, perhaps, and anybody else who thinks they're relevant, could independently meet and try and talk about this stuff. Does that seem reasonable?
Yeah.
Yep.
And try and, I mean, you know, what we're looking for, I mean, you know, look here, I like this idea of, you know, a kind of a, I mean, that's like a multi, that, you know, outer product thing there, isn't it?
Maybe the outer products of inputs, because they're basically, you can either take the tensor product of processes and the actual wires too. So maybe multi represents the wires, not the process.
Yes, I understand. Look, I mean, you know, this is going to wind up being some new notation, a bunch of new functions. I mean, just like we have list manipulation functions, we have graph functions. We're going to have some other collection of functions that represent that manipulate these kinds of objects, and hopefully all these various things, whether it's control systems, you know, neural nets, etc., can all basically flow. I mean, the concept is, what we want is a meta structure, in the same way that our tree structured expressions are a meta structure, where with specific heads they mean particular things. So in a sense, what we want here is, you know, just like we have expressions, we have associations, whatever, we have, you know, we want something that is a generalization of tree structured expressions, which we can make use of for these different applications by essentially putting in different heads. Does that make sense to people?
Yeah.
Yeah.
It's an interesting project. It's an important project because you know, the fact that we're seeing all these different areas make use of the same basic ideas. And by the way, once we have this, certain things become sort of obviously parallelizable. And just like we have, you know, what I predict, just like we have parallel map, for example, which is the, you know, a thing that parallelizes over lists. So we'll be able to have some kind of parallel, you know, parallel directed acyclic evaluate or something that operates over these kinds of things, and that parallelizes when it can, and, you know, serializes when it has to, type thing, based on whether it's, you know, monoidal or an ordinary, you know, morphism type thing.
That's one of the things I was doing with the LLM graph too. Like, it would do as much of it as possible asynchronously.
Right.
And then figure out the dependencies.
Okay, we've got a lovely thing here to build. This is important. Okay, I'll talk to you all soon. Thanks a lot, guys. See you later.